Hi, and welcome to this on finding angles. And you're probably wondering why is there a picture of an angel? Well, strangely enough, the number of people who sadly misspell angles is quite scary. But all good. So she can continue praying and we'll continue with finding angles of right angle triangles. Now this is part of a trig lesson, and so the key question, in fact there's only one key question, so it's not going to be a hugely long lesson, is how do we find missing angles when given two sides of a right angle triangle? Well, as a quick recap, here is my right angle triangle. There is, let's say, my reference angle. And knowing my reference angle, I can list my opposite, my adjacent, and my hypotenuse. Now remember, hypotenuse is the longest side, and the opposite is the one that is opposite the angle. Knowing this information and using our silly old Harry caught a herring trawling off a America means, otherwise known as SOHCAHTOA, means that we can use this information to find missing angles, or in fact missing side lengths, but not in this lesson, for right angle triangles. Now I should make sure that I write my right angle there, and again this only works for right angle triangles. So please don't try and use this in any other way, and there's right angle triangles. So first things first. We love a little play on words, a little mathematical pun. Do you see what I did here? Yes, that's a sine. Yeah, I know, it doesn't get any better. Carrying on, I promise you. Here is a sine, and please, ladies and gentlemen, it is not sin. Just thought I'd point that out now, and please just make sure it's sine. So we're going to find the missing angle using sine. Here's my right angle triangle. Let's call that theta. And again, we can call it all sorts of different things. It could be alpha or beta or x or anything that it wants it to be. But I think for convention's sake, we'll use theta. And I'm going to say my opposite side is going to be 4 and my hypotenuse is going to be 8. Now I've obviously pre-done that, and because we are trying to use sine, my advice, and in fact I would ask, that you always write the identity out. Sine is opposite over hypotenuse. Now again, if you're not sure why, sine is S and it's so for SOHCAHTOA. All right, so SOH, which if you remember rightly, or in a previous lesson I said, well, let's write it as S with the O on top of the H, which gives me the O on top of the H. Now the reason it's a really good idea to write this is, number one, generally speaking, it's always worth 1 mark in an exam. We like to give marks for you to be able to say it's the right identity. But the number of people who think that they substitute values the right way and actually do it the wrong way is quite scary. And by that, what I'm saying is, we don't know the angle on this one, so it's sine theta is equal to the opposite of 4 divided by hypotenuse. Now, if you got those the wrong way round and you put the hypotenuse on the top and the opposite on the bottom, your calculator would actually say something along the lines of undefined, which can mean a whole host of different things. Right, so here we go. What do I want to find? I'm trying to find theta, but at the moment it's got this sine stuck to it. Well, the good news is we can undo this sine and leave theta on its own by doing sine to the minus 1 of 4 over 8. And it's no real surprise that your calculator, be it the ClassPad or the TI Inspire, has a function called sine to the minus 1 of theta. And that's exactly what you put into your calculator. Now, when you do that, sine to the minus 1 over half actually works out to be 30 degrees. You're going to say, how do you know that? And I'm like, well, there are certain ones that I've actually learned, which makes me sound a bit geeky and sad, if I'm being particularly honest. But when you get to VCE, actually adding these things or remembering these things is really important. Now, if you've tried that on your calculator and you did not get 30 degrees, this is where huge problems actually come in exams. All right, by the time you get to year 11 and year 12, you're actually going to start doing angles in a whole new measurement called radians. Now, radians are awesome and they make life a lot easier for all sorts of different things, but that's beyond the scope of this video. The point of it is, you need to make sure that your calculator is not in the RAD mode. How do you know what mode it is? Well, for the TI Inspire, you have to go into your settings and make sure that it actually says, what are we looking for, degrees. If you have the class pad at the bottom of the screen, I believe somewhere here, it says something about like DEG or RAD. There might be another one, but we'll come back to that. If you use your calculator and it is not in degrees mode, then sadly, you're going to end up with the wrong answer. So it's always a good idea in an exam to make sure that your calculator is in the correct mode. All right, so that's sine. Now let's look at cosine. You see what I did here? Awesome. All right, cosine. Now when you actually cosine a document, maybe a mortgage, anyway, it's got nothing to do with cosine. So let's have a look at this now with our right angle triangle. Here we go. Right, there's my right angle. Good. I'm going to mix it up and I'm going to put theta here. Now I know that cosine is caught a herring, or CAH, so cosine of the angle has got to be the adjacent divided by the hypotenuse. Now you're going to say, well, hold on a moment, I haven't actually got any information. Nope, I certainly have not. So this is going to be, let's make this 4 and let's make this 12, for example. Right, is that my adjacent? Yes, it's my adjacent and my hypotenuse. So I'm going to put some figures in. Cosine of theta is equal to the adjacent, which is 4, divided by 12. I'm trying to get theta on its own. So I'm going to shift that cosine to the other side of my equation. When it moves to the other side, it becomes cosine to the -1. And that function again is on your calculator. So putting that into my calculator, and that came out to be 19.47122063. And I would imagine that goes on. Now again, we need to make sure that we give our angles to an appropriate degree of accuracy. And generally speaking, questions in the exam will always tell you to round it to 1 decimal point or 2 decimal point, or maybe they'll say to round it to the nearest whole degree. In this situation, let's round it to 2 decimal places. And so my theta would give me 19.47 degrees. And again, you will only get that value if you have your calculator in the correct mode. This guy here has a really bad tan. Yes, I know, I'm really sorry they don't get much better. And here's my right angle triangle. Now again, I'm going to mix things up a bit and I'm going to put my theta here. But this time I'm going to do 3, 4, and 5. Now I know that triangle actually exists because it's a Pythagorean triple. And if you have no idea what a Pythagorean triple is, Google it. All right, they are absolutely amazing. And they are certain triangles that we use in exams to try and trick you, or in fact to actually help you with your calculations. Now, I've actually given you 3 pieces of information here, and I'm deliberately trying to trick you because actually I can give you too much information, and lots of exam questions will give you more information than you need, which is really sad. So in this situation, you know that for tan of the angle, you've got to have the opposite divided by the adjacent. So we don't know what the actual angle is. What's the opposite to my angle? That's the 4. And divided by my adjacent, which is the 3. So actually this 5 is completely irrelevant to us. We can just ignore it. And my advice is, if they give you too much information, choose the ones you want and ignore the rest. So again, theta becomes tan to the -1 of 4 over 3. So putting that into my calculator, tan to the -1 of 4 divided by 3 gives me the wonderful value of 53.13 degrees to 2 decimal places. And I'm going to put 2dp in brackets just to help. So that's the basics here, but, you know, actually, life is like a box of chocolates, according to Forrest Gump. But in here, life actually is more interesting in the sense of we want real-world examples. So a ladder reaches 5.5 meters up at a wall and 2 meters from the base of the wall. Find the angle the ladder makes with a horizontal. Right, now that absolutely confuses people because it's like, well, what does that mean? First things first, do not try and visualize this, all right? Always draw a diagram. For every single question, my advice is draw a diagram. And I've said that here, it's a hint. I don't need to be sitting there actually drawing a work of art. Here is my wall, and there is my ladder. I'm actually just looking for a right angle triangle. So what does it say? A ladder reaches 5.5 meters up a wall. So it says that that is 5.5 meters, and it sits 2 meters from the base of the wall. That's just code for saying, well, that's 2 meters away. Find the angle the ladder makes with the horizontal. Well, this line here is the horizontal. And so hopefully that's the angle it's looking for me to find. Well, now we've got to try and work out what information have they given me. Well, that's my opposite. That's my adjacent. And I think from Sokotoa, it's what do we get? We get toe. So tan of the angle is equal to the opposite divided by the adjacent. Writing out the identity to give me that 1 mark. Tan theta even is equal to 5.5 divided by 2. Theta is equal to tan to the minus 1 of 5.5 over 2. Remember, it's the theta we're trying to get on its own, so the tan has to move. And putting that into my calculator of tan to the minus 1 of 5.5 divided by 2 gives me 70. Oh, hold on. Check the question. Correct to 2 decimal places. 70.02 degrees. Put the degrees, 2 decimal places in brackets, although that for some reason said 2pd. We'll try that again. 2dp. And we get that value of 70 degrees. Now, you're probably looking at my diagram and going, well, there's no way that's 70 degrees. I must have made a mistake. My sketch is wrong. And there's the point. The word is sketch. It's not accurate. If this was accurate, that's 2 meters away. That's 5.5 meters away. My sketch should realistically have been something like this, which would make that more realistic as 70.2. But a sketch just helps me visualize this. Now, as an aside, and we've pretty much finished the stuff on sine, cosine, and tan and finding angles, but what you might like to do is, firstly, load up this desmos.com/calculator. It is a fabulous online resource to help you visualize things. I wonder if any of you have wondered what the sine graph actually looks like. What is this sine graph? Well, ladies and gentlemen, drum roll please. No, there won't be a drum roll. Here is the sine curve. Now actually, it's only a very small part. This is a small part of the sine curve. Why? Because actually it extends on to infinity and beyond in both directions. Now what we find out here, there is 0 degrees, there is 360 degrees. We find out that actually it repeats. It has exactly the same shape called a sinusoid. Oh, sinusoid, like sine, that actually goes on and repeats. Now it has a maximum value here at 1, and it has a minimum value here at -1. And for those of you who know anything about electricity, what you'll find is actually that is what electricity looks like. It follows this sine wave, and about 50 of those every second, which is pretty awesome. If you're wondering what this means, well, what I'm telling the Desmos to do is do y equals sine theta, and these curly brackets say, well, I only want to see a part of it. I only want to see the bit that falls between 0 and 360 degrees. And there is some really great stuff to be had here. So for example, if you want to look across the graph at the value of 0.5, we actually notice there are 2 angles that give me the sine of 0.5. 30 degrees, which we already knew. But if you put into your calculator 150 degrees, as in put sine of 150 degrees, you're also going to end up with a half. So sine of 30 is a half, and the sine of 150 is a half. Well, the mind-blowing thing is they're not actually the only 2 values. Because this thing goes on to infinity and beyond that way, and on to infinity and beyond that way, there are lots and lots of angles that will give me an answer of 1/2. Now, more on that coming later on in the course, but that's what sine looks like. What does cos look like, or cosine look like? Well, there we go. Cosine looks like same thing, maximum of 1, minimum of -1. Only showing you a snapshot between 0 and 360 because it extends off to infinity and beyond. Here, interestingly, it looks exactly the same on one side of 180 as the other. But what you may not notice, or what you may realize if you were actually to say change this between I don't know, minus 360 and 360, for example, is that this has exactly the same shape as the sine curve. In fact, they are exactly the same shape. The cosine curve is the sine curve that has been shifted 90 degrees that way. Whoa, why? Well, we come back to that later. But for completeness, here, ladies and gentlemen, is the graph of tan, which I think is pretty funky. Now, what you'll notice is there is a line here that we never see, called 90 degrees, and also there's one at 270 degrees, where the graph never ever touches. If we were to zoom out of this, and I've only done a small part of it, what we actually find out is the line, this graph here, goes further and further down, and it gets closer and closer to this line, but it never touches it. And it gets closer and closer to this line, but it never touches it. Now, this line here is actually called an asymptote. Right? And they are fabulously used in methods 1 and 2 and methods 3 and 4, probably a little bit outside the scope, but an asymptote is basically a line that a graph will get closer and closer and closer to, but will never cross. Right? And there's a reason why the value of 90 degrees for a tan graph actually has this asymptote. What it means is that for some reason, 90 degrees is not possible for tan theta. If you put tan of 90 degrees into your calculator, you would probably get undefined, right? Or something that means, no, sorry, mate, not possible, right? Infinity, maybe, I'm not sure it'll say infinity, but knowing these sine, cosine, and tan curves actually is really, really useful. So I threw it at the end of this just for some sort of help. All right, that's the end. I look forward to seeing you next time.